Bismillah. So we're going to be talking about this recursion, and the recursion is about it's like, in short, it's a method that calls itself. That's what recursion is. Now, some kind of situations require recursion because some things are defined in a way that they're based on something on itself. Like, for example, the set of natural numbers 0, it starts with like 0 is a natural number, and then if any number n is a natural number, then n plus 1 is also a natural number. So then you get, it's something that defines itself with itself, something like that. And another kind of example, let me show something like this. Like, this is the definition of factorial. Factorial, this is how it works. If n is 0, it's the result of factorial of 0 is 1. And then if it's not, if the n is greater than 0, then the factorial of n is n multiplied by factorial of n minus 1. Let's talk about that. Let me bring my my paint. So we said that factorial of 0 is equal to 1, and then for any other number greater than 0, factorial of that number is equal to the number multiplied by factorial of n minus 1. So basically you define factorial with factorial, which is kind of the recursion, what it's all about. Now, for example, if you say 5, factorial of 5 is equal to what? So it's equal to 5 multiplied by factorial of 4, which is equal to what? Factorial of 4 is equal to what? So, which means this is equal to 3 multiplied by, 4 multiplied by 3 factorial. With 3 factorial, it's what? It's 3 multiplied by 2 factorial. And 2 factorial is what? 2 multiplied by 1 factorial. And 1 factorial is 1 multiplied by 0 factorial. And 0 factorial is 1. So this is where we stop. So it's some kind of a loop until you have a place to stop. And that's what's very important in a recursion. You always have to put a condition that will make this stop. Because if you don't put this, and you just keep this rule, it will never stop. Because now you arrive to 0. 0 factorial is 0 multiplied by minus 1 factorial. Minus 1 factorial is minus 1, so it will never stop. And that's an infinite loop. So that's the idea behind the recursion. And there's a lot of things that are based on recursion. Let's say this Fibonacci sequence. The Fibonacci sequence means like this is a function that is equal to n if n is 0 or n is 1. Or it's equal to the Fibonacci of n minus 1 plus the Fibonacci of n minus 2. So for any n, let's say we do something easy. Okay, then I always have to erase everything. Oh, just the easiest way, new. Don't save. Now we said Fibonacci of, let's say, 3, because I don't want to write a lot of things. We said Fibonacci of 3 is 3 0 or 1? No, obviously. Which means Fibonacci of 3 is equal to Fibonacci of 2 plus Fibonacci of 1. So this is equal to Fibonacci of 2 plus Fibonacci of 1. Now Fibonacci of 1, I know what it is, because I said if it's 0 or 1, then Fibonacci of 1 is going to be 1, because I say if Fibonacci of any number, is it going to be equal to that same number if the number is 0 or if number is 1? No, n now is 1, so f1 is going to be giving me 1. So that means this is 1. But what about this one? I don't know. I need to apply the same rule again. So which is Fibonacci of 1 plus Fibonacci of 0, because it's 1 minus 1, sorry, 2 minus 1. Now I'm talking about f2, right? f2 is 2 minus 1, which is 1. 2 minus 2, which is 0. Now this is equal to what?
1.
And this? 0, because f of 0 is going to be 0 if this is 0. And then this is the result. Then this is 1 plus 0, that gives me 1. And then this whole thing is 1 plus 1, so this is 2. What if it's bigger than 2? This is bigger than 2. We just calculated Fibonacci of 3. Now let's just can I do Control N? Yes. What about Fibonacci of 4? This is equal to what? Based on this, Fibonacci of 3. So f3 plus f2. Now what is f3? It's f2 plus f1. Okay. And what is f2? f1 plus f0. And what is f1? It's 1. Oh, f0? 0. So now f2 is going to be equal to, this is going to be this whole thing. Let me use another color. So this is going to, f2 now is going to be 1. Now f1, 1. So f3 now is going to be equal to what?
2.
To 2. And then let's go back. f2 is equal to what?
f1 0.
f1 plus f0. And then this is going to be equal to 1, and this is 0. 1 plus 0, that's 1, which means this is equal to 1. So the result of f4 is 3. But notice that the Fibonacci is calling itself twice, like it calls itself in 2 places. Like this fn is defined of f again n minus 1 and f again n minus 2. So that's why it calls itself twice. Now this is the same thing we've been talking about, except that I'm not happy with the way it's presented. There's a lot of things that uses that kind of definition. Now anything that is recursive will generally have something that says where we stop, and this is what they call the anchor or the base case, and well, and then something that makes the repetition. So like this is the anchor, this is the inductive step, and the anchor. The anchor is where we stop. If you don't have that stop in that anchor, it becomes an infinite loop. It becomes something that the computer will never stop. It's like an infinite loop. Yes? What do you mean by up?
You make the number go low. What if you want to make it up? Like I want to found.
I'm not sure to understand. You said low, low, low. I didn't get that. You see, I'm not like some of you. If I don't understand, I'm not going to let you go and then see, inshallah, maybe later on I'm going to understand.
It's like we take it 3.
Okay.
Go to 2.
You're talking about which one now? The Fn, right?
Yeah.
Okay. Fibonacci. Yeah. What's the question then?
Question: what if we make it add, not?
What if we make it add?
We make it more increasing. Because
Like what, for example?
n minus 1? What if it is
Ah.
n plus 1?
Well,
We continue until
it's
the n
okay.
equals-
I get your question now, which means now, what you're saying, instead of doing n minus 1, I'll do n minus n plus 2 and n plus 1, something like that, right?
Yeah.
Now it's impossible because
I mean,
in your anchor, I know in any other situation, unless if you'd like to make something like this, well then your anchor should be in like a big number. Now you say, for example, if the number is 100, n is going to be 100 and or 101.
so it's have to do something.
So now you're going to go backwards. So you say, okay, this n, well, what is the end, and what is going to be the question anyways, if you'd like to get that? Because now you know something, and you'd like to know based on this thing what's coming up next. Now if you're doing it the other way around, which means your anchor is what is going up next, so what would be the question from where we start? Or I don't know what kind of question might have, might be
The
used.
question is, he wants to know the add of number from 1 to 10.
The what?
The add of number from 1 to 10.
Okay.
So the n, it will be the one starting from 1 and keep it increasing and adding until he arrives to 10 and stop.
Well, that's not how you're going to make it, because you said now if you say you'd like to have some kind of function, let's say I'm going to call it s. Now s of n is going to be equal to, okay, what is going to be the first step when n is equal to what? 0 is going to be 0. What I mean, this is going to give you 0 if n is equal to 0. And then what would be the next rule? If you would like to add the sum from, I mean, 1 to 10 or something like that. So how can you write it this way, like a recursion? If n is equal to 0, I get 0. If not, that means if it's equal to 1, I'm going to make it 1 plus 0 or something like that, or 0 plus 1. So the same thing like the factorial, but with the plus instead of the multiplication. I can do something like this. It's n plus, oh no, let's make it a decent plus, s of n minus 1. Now if you say s of 3, this is going to give you what? 3 plus s of 2, which is 2 plus s of 1, which is 1 plus s of 0. This is 0. Let me just check another color. This is 0, so I forgot the plus. So which means this is 1. 1 plus 2, that's 3. 3 plus 3, that's 6. And then the sum from 0 to 3 is 6. Because 0 plus 1, this is what we do. We take 0, we add it to 1, and then we add it to 2, and then we add it to 3. Now we can do this the other way around, like from 10. So, but it's not going to, no. I don't know how you can
Make
flip it
10
easily.
plus 1.
Okay, let's get your option. What s of n is going to be equal to what?
10.
10.
If n equal 10,
If n equal 10, comes 7. Then what? This is f s of 10 is going to be equal to what?
what the down right n?
Well, your problem is here. This is the problem. You have to calculate yourself. Then, what's the point of all this? I mean, Now, generally, this is how you start. You start from something and you keep calling what you know already. Now, if you do the plus, you don't know something. I mean, you would like to use a formula to get something that you don't know. You need to use what you know to get to what you don't know. That's what this recursion is all about. Yeah, okay, Sn. I'm sorry. He wants to. He insists. So let's go to the end. If what?
10.
What do you mean 10? So this is going to be equal to 10?
If n equal 10,
If n equal 10.
then it will give you 10.
Okay.
Then we write
Mhm.
down if n less than 10,
And okay, it will be equal to what? If n less than 10, okay.
n less than 10,
Alright.
then it will be n plus fn.
N plus
Fn
Sn.
with the plus also. N plus 1. Sn plus 1.
Plus 1. S n plus 1. Okay? Is that okay? Let me give you something. Give me this.
Now it's bigger.
So it doesn't work. Okay, let's try something else. Give me this.
1 plus s2.
So this is going to give you 1 plus s2, which is 2 plus s3, okay, plus etc. until
S10.
9 plus s10, right? But then s10 is going to be what? 10. And only in this case that is going to calculate you to give you from 1 to 10. Yes, but you have to start with 1. So you know where to start, you know where to stop. Well, fine. I mean, you're right. Now this way, you're successfully made a recursive method that adds from 1 to 10, using not what you know, but where you're going to be.
But it's need also that if when it is bigger than 10.
Yeah, exactly. You have to stop.
But what if we have started for 5?
Well, then it's going to count from 5 to 10. So it's the Qasim's method of calculating. But it's, I mean, the idea is the recursion using a plus to reach something. But generally, this is not how it works, because you can see it's very limited what I can do with this. However, if I'd like to have the sum of any number from a specific a place when we start, an initial this anchor thing, until where we stop, we do this kind of like from what we're going to be the limit, and then we keep based on what we know what we can get later on. You wanted to say something else?
I can change the rule that I must have n.
You must have what?
I must have n connected to the rule,
Yes, of course.
but I can't change the rule.
The rule is up to you, but you make sure that one day that rule is going to reach the end. So that's the thing.
But teacher, I think it's the same the problem with the other method that we show us.
Which one?
What if we put the negative number? Like
Well, if you put the negative number, it's not going to do anything. That's why the condition, you see, it takes care of what do we want to, or what the range of n that is acceptable. So if it's negative, it's not 0, it's not this, so it will stop. And well, there's a lot of different type of and this is, I mean, for the factorial, this is how to put this into action. And basically we have some code that I can show you. Let's close all. So this is the lab 6. There's something called test factorial, which shows this this is the factorial, the recursive version. because there's another factorial that I can use. Remember, there's another factorial that I can use. This is the one that we've done when we were working with loops. Recursive. If it's non-recursive, how can I do that? With the loop? Okay, what would be the loop? For? We start from n. Less than 0? If you put less than 0, it's not going to work. Bigger than or equal 0? If you multiply by 0, it's not going to work, because 0 multiplied by whatever is going to make it 0. So you don't want to reach 0.
Only bigger.
But all this is called
I minus minus.
And then I minus minus. Now what is going to happen, I start from n, let's say factorial 5. 5 factorial. This should be equal to 5 multiplied by 4 multiplied by 3 by 2 by 1, and then we stop. So this is going to be, what should I do now? N Alhamdulillah. Okay, so what do you think? Is that okay? What do you mean new value? New variable. Okay. What's this new? Let's call it result. Equal to 1. And then by n? Nope. Because if you put by n, it's going to be 5 multiplied by 5 by 5 by 5 5 times, which is not what we want. We don't want to multiply 5 by 5 by 5, but 5 by 4 by 3 by 2, and which one is decreasing is the I. And then I return the result, and now I can do that in 2 ways. I'm sorry, Qasim, you said?
For the method.
For calling the method here, yes, you're right. And now if I run this file, so if I type, let's say 5, so both of these gives me the same number, but then they work differently. Now to see this, how this works, I'm going to use this debugging. Have you seen this before? Have you used this feature before? Well, you should have. To see what's going to happen. And then what I'm going to do now, instead of running with this, I'm going to run with this. Is that okay back there? Yes? Sure. Because if you have something to discuss, it will be appreciated to discuss with everybody, so everybody also benefits. Line 19? Yes. Factorial of n? The question is, well, that's a good question, you see. If I do something like this, what is going to happen? Let's say factorial of 5. If 5 is equal to 0, no, then it's going to be 5 multiplied by factorial of 5. Oh, okay, just factorial of 5. Okay, so this is an infinite loop because factorial of 5 is if 5 is equal to 0, no, you're going to return not this, we're going to go into the else. What am I going to do? The result of this, you have to return factorial of 5. And then you call it again factorial of 5. What is factorial of 5? It's factorial of 5. Factorial of 5, factorial of 5, factorial of 5. So it will never stop. It's an infinite loop. Yes?
What if it's reached 0? It will be returned only 1.
Well, that's the thing. I mean, because we're going to be... Now, let's just have a look at how this is going to work. That's why this is going to help us, because we'll see actually the steps and what it's going to do. Now, if we call that factorial of 5, let's see now f is factorial. So this is going to be 5 multiplied by factorial of 4. Now, when I call factorial of 4, this is going to be 4 multiplied by factorial of 3, which is 3 multiplied by factorial of 2, and it's going to go not 2 multiplied of no, I like space now. I did not plan it well enough. Let's just start again. So I'm just going to represent this little bit without f. So this is going to be 5 multiplied by 4 factorial, and then this is going to be 4 multiplied by 3 factorial. And then, because the question is going to be, is the n is 0? No, so I'm going to go until I reach 0. So now let's see, the one that's going to be only 1 is not all of them, but one of them. Now this 3 is equal to what? 3 multiplied by 2 factorial, which is 2 multiplied by 1 factorial, which is 1 multiplied by 0 factorial. Now this 0 factorial will return 1. Not this whole thing is going to be 1. Just this is now because I called the method every time many times. Now in this last call of that method, it's going to give me a result that is a value, that is 1. Now this one, what am I doing with it? The other calls, I called the method factorial how many times? This is the first time, second time, 3, 4, 5. This is the 6th time. On the 6th call, I got 1. But then the 5th call is still waiting for the result. It's still waiting to get the 6th call to return something so I can calculate. So now it gets inside. Once I stop, I find my anchor. I'll go up now again to be able to find the answer. Now I have the factorial of 0, what it is. I'm not going to call factorial anymore, so I'm just going to now back up. Now 1 multiplied by 1 is going to give me 1. What am I doing with this 1? Now this 4th call give me a return something. Now this 1 factorial is 1. I'm going to multiply it by 2, which is going to give me 2. Now this one again, we have a value. We can give you the value of this, which is 2 multiplied by 2, which is 4. Now 4 multiplied by 3, 12. Multiplied by 4, 12 multiplied by 4. Yeah, the morning.
Okay.
Is it 4?
4 multiplied by 3 factorial.
That's what I meant.
Three
Maybe
multiplied
same
by
teacher.
2.
Factorial 2 multiply 3.
Yeah, you're right. 3 multiplied by 2. 3 multiplied by 2. That's not 4.
6.
It's 6. And then, so this is 6. 6 multiplied by 3.
6 multiplied by
4.
Like I'm saying. Is what?
24.
6 multiplied by 24? Are you sure? Because sometimes you said 18. It's 24. Because 6 multiplied by 2.
Because 6 multiplied by 3, it is 18. That's 6 multiplied 4. That's what we want.
Exactly.
24.
And then 24
Multiplied by 5.
by 5.
Which give you
120 we just saw.
120
Yeah.
The result what we see.
Now you said that this is not what you were asking for.
Yes, I mean the method will return only one value. At the end, it will be return only.
But which method? You know what you say every time at the end. This method returns only one value. Either it's 1 or it returns some number multiplied by the result of this method. So what does this return? We don't know. We have to run it. So that's why we added. Let's say factorial of 5. It's going to return 5 multiplied by another number, which is factorial of 4.
At the end, it will be 0.
No, it's not 0.
Return,
Yeah, you mean the number is going to be 0. Yes. So at the end, it's going to be 0. But how many times did I call the factorial before I can reach here? I called it. This is the first one. This is the one that we're inside. So then this is the second one. So look what's inside. We called it, in order to get the answer to this, I called it 1, 2, 3, 4, 5 times. Each one of these 5 calls needs to return a value, right? Each one of these did not return any value because it called itself again. Now the last one will return one value, which is 1, because the last one is 0. When it's going to be 0, we return a number. Here this is just like some kind of a loop thing that's going to make it repeat. So now this is going to return 1. That means we're going to be returning this one. Now what is I don't see it. Okay, it's here. So this is the one that is going to be returned. This one is here. Now that I have this method, this whole factorial of 0 gave me 1. But factorial of 1 is still waiting because it was called. That's why I wanted to show you here, because you're going to see those calls as a stack. Because when you do this recursion, it's a stack of calls. You remember the stack?
Yes.
First in, last out. So the first call is going to be the last to be evaluated. And the last one that was entered, which we can be evaluated, is going to be the one that is going to be evaluated. Once I have it, I just pop once I have that. So I push. As long as I'm here, when I reach this, I pop. That's the main implementation of that internally. But I would like you to see it. So what I'm going to do, I put this stop and this break. It's called a break. I'm going to break at this line, which means when I'm going to run, this is going to execute normally until it reaches here. I get inside, and when I get inside, I'm going to stop at this line so I can see things how they are working out. And then when I click on this, some other tools are going to appear, like these ones. Now you see, now it's waiting for me to, oh no, stop. I need to right click, and I would like to debug this file. So Control Shift 5, because this is the one that I'm interested in. Now look at here. This is the list of this is like the stack of calls. There's nothing, I'm just in the main, I'm running. It's waiting for me to enter something, and put 5. Now if I put 5, it runs. Now notice what is going to happen. I started from main. Now the main is calling factorial. I'm inside factorial, as you can see here. This is n. What I can do, I can show you the n here in a way that I can click on this one, so I can see it all the time. So n is equal to 5, and when it changes, we're going to see that change. Now this is going to be false, right? So if there's these buttons here allows you to get inside or get something, but this is step into, which means if you click on this, you get inside the method that is going to be called. And that's what I'd like to go. I would like to go inside this method factorial one is going to be called. So there's nothing to go inside here, so it's safe to click here. So now you can see this is false. I'm going to get inside. So now look what is going to happen here. If I click here, I'm going to go inside. Now n is what? I'm inside factorial with n4. But look here, factorial 5 that was here is still waiting. Now this is factorial 5. This is factorial 4. And then factorial 4 is going to go again inside factorial of 3. And this is exceed now, and this n is factorial 3, and then I have another call of factorial. Factorial 3, then it's going to be 2, there is going to be 1, there is going to be 0. Now look what is going to happen. When it's going to be 0, I'm going to be true. So this is going to return 1. Now once I return 1, there's nothing to do, but now I know the value of this one. I know that this is going to be 1. I mean for n, when n is equal to 1, this is going to be n minus 1, which is factorial of this thing. I don't know if I can select that. If I select it, no, it doesn't. So now notice that this is going to get to be reduced now. If I get inside, but there's no inside, it's just a value. And then this is going to be, now for now n2 I know the value, for n3 I know the value, I know the answer, and then now I know the answer of this when n is equal to 5, because this is going to be the value that I just calculated, and I'm done here. I go back, and I'm here now. I know that factorial of 5, this is what it is. So I can now, if I run this thing, while this, I shouldn't have gone this. Now if I keep running this, let's see the output. I got this factorial of 5 is 120. So what happened is that it memorizes all these calls, and then once it finds the answer, it answers the calls one by one until it goes back to the initial call, and then I have the value. The same way that we did right here. It just keeps going, keeps calling until it reaches this anchor thing. Once it gets the anchor thing, I get the answer for one of the calls. Once I get the answer for that call, I can get the one that was before, until I reach the one, that initial one. So even though it shows that I'm returning 1 here, actually I'm going to call this, because I'm calling it many times, it's going to return many values. Each call is going to return a different value. So that's what this factorial is all about.
Directly it will add them together.
It will multiply them together.
Yes.
Yeah. But as you have seen, recursion requires to remember that we called, because that's what happened when we called with factorial of 4 or 5, we could not answer, so it called again with factorial of 4. So this is stored somewhere in the memory, and then you call again factorial with another number. So it keeps them in the memory until you reach the anchor, and when you reach that, then it just comes back. So there's also some kind of, there's an advantage or disadvantage of everything. So it takes some memory, this kind of, because it needs to remember the state of n. Now as you can see, n changes. Even though I'm here, the initial n was 5, but because I'm doing this, I'm calling factorial with the n minus 1, I have different n's. So each stage, at each stage, the computer needs to remember at this stage what was n, at this stage what was the n, what was the value of the n at this stage, and so on. So it's some kind of memory that is involved. Yes? Any question? So that's the main idea. And then you can apply this to a lot of different kind of scenarios. This is the Fibonacci. This is how you implement that. So if n is equal to 1, n is to 0, or n is equal to 1, that's what you say. We return n, and then or else we return Fibonacci of n minus 1 plus Fibonacci of n minus 2. And of course, we need to make sure that the n is positive, because if we don't, this is something that is missing, because we need to put something there. Now, for example, even for this one, something is missing. Like, for example, if I run it, let's shift F6. If I run it with minus 5, stack overflow. What does this stack overflow? Stack overflow means there was a memory allocated for the stack, and it was doing some recursion, call itself so many times that it reached the maximum of that memory, and then it tried to do another recursion, and the memory was full. It just tells you stack overflow, because you're trying to put something where there's no space to put in it. And if you'd like to see it at work, let's just try it again with this here. Control Shift F5 is going to run it, and I'm going to enter just -1 is enough, because -1 is going to be -1 multiplied by -2, -2 multiplied by -3, and this is going to never stop. And let's see that. Now this is a shortcut is F7, so if I press F7 I don't have to click. So look at this, what is going to happen. So let's just have a look at n, let's say, just to stop to track n what it is. So let's see now -11, it's just going to keep adding. See the stack keeps growing. I don't know how many they're going to be. There's a lot of elements in there, and you can see there's a lot of them. I don't want even to count, but you can count to 6, 7. So look at the number. So it's a lot of calls there, and then one day it will just reach the max, and it will tell you, okay, stop. There's nothing more that I can add. But this is, as you can see, some kind of an infinite loop that breaks. So what we should do, I can do something like this, for example. So if it's negative, I'll just return 1. Or I can do something else, which is put it like this, leave it like this, and then put another, no, just maybe another if else if, for example. So I'm going to say, like, if it's is it still running, or what's going on? Oh, this is probably a bug, because this should not be here. It's still running, actually. Oh, I made a problem. Anyways, it's hanging. I should have stopped the program, then did something. Then I'm using a lot of memory probably with all these calls, and I forgot to stop. So now it's yeah, and task, and let's start it again. Okay, let's go back, source, and then we were talking about this test factorial, and now what I can do something like this, and what I'm going to say, for example, if it's less than 0, return 0. I don't know. So if it's negative, I'm going to return 0. If it's not negative, if it's 0, I'm going to return 1, and then else is going to do the recursion. Now if I run it again, this one, Shift F, just F6. If I enter with one, oh no, what is that? Shift F6, okay. So I need to stop this one. Shift F6. So if I now run it with -1, I just get 0, and this one gives me 1. Why does it give me 1? Because when this is -1, is -1 greater than 0? No. So return. So I'm not going to get inside. I'm just going to return this, which is going to return 1. So if I'd like to get the same result, I can do basically this, and this is going to give me the same result. Now if it's negative, if it's 0, it's going to return 1. So if it's less than 1, so this is going to be just, I'm doing just this so I can show you. Oh, not again. Shift F6. So you can see that I get the same result. Now if it's -1, both of them are going to be giving me the same value. So for the Fibonacci, I need to do the same, because I need to do something that is going to be like less than. If it's less than 0, I need to do something, because now if it's -1, -1 is equal to 0, no. -1 is equal to 1, no. So I've got here Fibonacci of -1 -1 plus -1 -2, which is again is an infinite loop. And well, there's others like this reverse print naturals from n to down. So that's the main idea. Now what I'd like you to do is to practice this So you can just don't save. So you do something similar, and I would like to go for the labs. Now you have these are the files that are given to you. I would like to be doing those tasks. The first one is to write a program that reads an integer n from the user and then print all even numbers between 0 to n using recursion. You can some kind of something like that. So just to practice the recursion.
So we have two here for the